Okay, so now that we're through with the basics of segments and angles in the circles, we're going to really start drilling down into each of those. So today we're going to look at angle relationships in circles and how those relate to arcs and chords, I should say not cards, chords, and then whether the angle's like inside the circle, outside the circle, etc. So the first thing that's really an angle relationship, but we already learned about it, we learned about it yesterday, is when an angle has a vertex that's in the center of the circle. But this just goes back to what we did yesterday. In all honesty, it goes back to what we did yesterday. So looking at our circle, we're going to do like we did yesterday. We're going to get everything we can possibly get, and then look at what it's asking us for. So first thing I see is a vertical angle here. AFE and BFC, those are vertical angles. They're going to be the same on each side, 97.4 degrees. Now, I noticed that from B all the way to E, I noticed that that is a semicircle. So that should add to 180. So that's what I'm going to do. I'm going to add the two that I have, 97.4 and 52. Oh, we got those 0.4, 9, 149.4. And then I'm going to subtract that from 180. Give us 30.6. So this angle right here is 30.6 degrees. Make that a little bit smaller. Everything up there. There we go. Okay, now I need to go and get the one that goes from A to B. Well, A to C is 180 degrees. Do 180 minus 97.4, which is going to get us, let's see, 82.6. This one is 82.6 degrees. Okay, now let's see what the questions are actually asking. Ask us to find the distance find the arc from B to D. So from B to D. Well, I'm going to add 97.4 and 30.6. That would give us 128 degrees. Then they ask us about BAC. Since there are three letters here, we have to go the long way around. We start at B, hit A, go around to C. So I need to add 82.6 plus 97.4 plus 52 plus 30.6. So if I add up all of those, it would get me 262.6 degrees. And I just noticed I was so excited to just jump right into it that I didn't even fill in our formula. So this is the same thing as what we did yesterday. The measure of the central angle is the measure of the arc. Whatever the arc is, that's what we use. Now, another way to do this is with a pie chart. This is another application. So the circle graph shows the types of music sold during 1 week at a music store. Find the measure of each. All they did differently here is they divided it into percentages. So for instance, I want BC, arc BC. Well, arc BC goes from B right here to C. That's the wrap wedge, which is 13%. So I need to get 13% of 360. .13 times 360. I think that's 46.8 degrees. That's all we had to do. Next one asks us about the measure of angle FMC. FMC. So that includes FMC includes pop, country, and R&B. So we need to add those together. 9 plus 10 plus 11. It's going to get us 30%. So then we do 0.30 times 360. Which would get us 108 degrees. And the last one for this example. It wants to go and find the measure of arc AHB. AHB. Well, what do we know about that one? It includes everything but this 25% right here. So it doesn't include a quarter of the graph. It doesn't include rock. What's 100% minus 25%? We do this the short way, so I don't have to add up all of them. 75%. So 0.75 times 360. That gets us 270 degrees. Now, just a little fun fact for you. This is actually the reverse of how you would build a pie chart. So if you were to take statistics, which I teach dual credit statistics, when you go to teach a pie chart, if you know wrap is 13% of your vote, if you will, then you would do 0.13 times 360. And then you would draw an angle that has 46.8 degrees within your circle. And that would be your wedge for rock. If you knew rock was 25%, 0.25 times 360, that gets you 90. So your rock one has to be a right angle. You would draw that. And you would just keep going around the circle until it's all filled. But anyways, I digress. So now we're going to talk about angles that are inscribed in the circle, meaning they're inside the circle. An inscribed angle is an angle whose vertex is on the circle and whose sides contain the chords or contain chords of the circle. So like angle DEF, that is inscribed. An intercepted arc consists of endpoints that lie on the sides of an inscribed angle and all the points of the circle between them. So arc DF is an inscribed arc. Excuse me. Arc DF is an inscribed arc. So that brings us to another theorem. The measure of an inscribed angle is half the measure of its intercepted arc. So it doesn't matter how the angle is drawn within the circle. If it's inscribed in the circle, the angle is half of the arc. Or you could say the arc is 2 times the angle. It just depends on which way you go. If you're starting small, so you're starting in the angle, sorry, I said that backwards. If you're starting with the angle, multiply by 2, that gets you the arc. If you have the arc, my hand's doing weird things on this camera. Hang on. If you have the arc, divide by 2, and that gets you the angle. So multiply, divide. Like on this example, they want us to find the measure of angle RST. RST. We want to figure out what is this angle right here. I have RT is 120. I'm big, I need to go small. I'm already big, I need to go small. That means I need to divide by 2. 120 divided by 2 gets us 60 degrees. Now they ask us about the measure of arc SU. Let's see. I need to go big. All I have is the small. I have 40 degrees down there. I need to go out. So I'm small and I need to go big. What do? I multiply by 2. So 2 times 40 gets us 80 degrees. Okay, let's look at the next one. They want us to find the measure of angle BCD. BCD. So I need to find this angle right here. Well, again, I know this 142. I'm big. I need to go small. I'm already big. I need to go small, which means I need to divide by 2. 142 divided by 2 gets you 71 degrees. Then they ask you to find the measure of angle ABC. So ABC. Now that one, you can almost look at that one. That is a semicircle. Using our vocab from yesterday, this is a semicircle. So it's going to be equal to 180. Okay, so there is the front of the notes. Let's flip over and go to the back. Okay, so if the vertex is inside the circle or outside the circle, it's not on the circle like the ones we just did. The vertex was on the edge of the circle. Okay, here's my circle. The angle came off of it. You know, that doesn't even make sense. It kind of came off the side like that. No. Now we're in the middle of the circle. Or we are completely outside the circle. We're not even trying to get inside now. So if it's on the inside, if we call this one angle 1, the one right across from it, angle 2. Again, notice this is not in the center. So this is not in the center. The measure of the angle is half the sum of the measures of its intercepted arcs. So it's arc 1 plus arc 2 divided by 2. You're adding these together, that one and that one, and then dividing it by 2. Now, if we are totally outside the circle, like on these next ones, then we have to subtract the arcs. So you would do the large arc minus the small arc divided by 2. That one might be a little confusing, so let's see it in action. Let's look at A. For A, the vertex is outside the circle. So we're going to do the large minus the small. 174 minus 98 divided by 2. Let's see, that's going to get us 76 divided by 2, which is 38 degrees. That's what X is. X is 38 degrees. Okay, B. Notice that the small arc right here and the big arc make a full circle. So they only need to give us one of them and we can figure out the other. 360 minus 132 going to give us 228. So this one is 228. Same process though. 228 minus 132 divided by 2. Because our angle here is outside. Anytime your angle is outside, you subtract. Let's see, that's going to get us 96 divided by 2, which is 48 degrees. That's those two. That's what happens when the vertex is outside your circle. This next example, they want us to find the measure of angle SQP. Angle SQP. But we have a small issue. The formula that we know that says you add the arcs together, the two arcs. So the 100 plus the 32, and then divide that by 2. That formula, let's work it out. It's 132 over 2, which gives you 66. This 66 degrees is talking about this angle and this angle. Is that the angle they ask us for? No. We want to find SQP. So now, this goes back to a line. This whole thing is on a line. A line is 180 degrees. So 180 minus 66, that gets us 114 degrees. There's the measure of angle SQP. So 114 degrees. And so is the one below it for that matter. Okay, there is our lesson for day 2. Stay tuned for the guided practice.